All right, welcome geometers. In this video, we are going to take a look at more conditions for triangle similarity. We currently have two methods for determining if triangles are similar. We have angle-angle similarity and side-angle-side similarity conditions. But we're going to investigate today if these are the only ways to determine if triangles are similar, or are there other methods. So, just to review, if triangles are similar, in order to know triangles are similar, I would need to know that all three pairs of sides are proportional, and I would have three pairs of congruent angles. That's what makes triangles similar when we first started this. Now I have two shortcuts in my theorems with angle, angle, and side, angle, side that we worked through in the previous section. But we're going to look and see if we can find some other shortcuts so I don't have to always check the 6 conditions. Okay, so keep the following questions in mind. How much information is needed? Are the triangles similar, and how can you tell? And can I find a triangle with this information that is not similar? Okay, so we're going to start here. Robles' team was using the side angle side similarity condition to show that two triangles are similar. This is too much work, Robles says. When we are using the angle-angle condition, we only needed to look at two pairs of corresponding parts. Let's just calculate the ratios for two pairs of sides and make sure the triangles, to determine if the triangles are similar. Okay, so if two pairs of corresponding sides share a common ratio, do the triangles have to be similar? If not, what additional information is needed? And that's what we're going to look at today. So let's investigate this idea of side-side similarity. I have a digital tool here that I'm going to use. It's an animation using the tools in our ebook, but I'm going to link two sides together. I'm going to lock in the two sides. So I have paired two sides with each other to have the same ratio. I can see those listed there with the 2. Now, as I continue to play this, I want to watch those ratios. Now, while those sides, as I've moved the different angles around, those sides have remained with those same ratios of 2, my third side does not have equal ratio. And if you remember, in order to have similar figures, all my sides need to be proportional and my angles need to be equal. Well, in this case, I can see that two pairs of sides are proportional, but this third pair of sides does not have the same ratio. So these triangles are not similar, because not all three sides have the same ratio, and that is a requirement of similar figures. So I know side-side similarity is out. It is not a valid triangle similarity theorem. So we're asked, what other triangle similarity conditions involving sides and angles might there be? List the names of every other possible triangle similarity condition you can think of involving corresponding angles and side lengths. Well, if I think of my triangles, I have an angle, a side, an angle, a side, kind of all the way around here. Now I already know angle-angle similarity works, and I already know that side-angle-side similarity works. So I need to know what other lists, what other theorems can I check. We thought maybe side-side similarity works, but we learned that one didn't. So as I'm building out this list to check, I kind of want to think of what's the shortest possible it could be. So maybe it'd be something else with just 3 pieces of information. Maybe I just knew 2 angles and a side, or maybe 2 angles and a side in between them. Or maybe it's 2 sides and an angle not in between them. I don't want to do 2 sides with the angle in between because I already have that one. Maybe it's just 3 pairs of sides. Maybe I know 2 sides and a couple angles. Okay, but as I get into this, I'm getting into some redundancies here. So let's take a look. I could also list, like, what if I knew 3 sides and 2 angles? Or 3 angles and 2 sides. This list looks daunting, but I promise you it's going to get short real quick, because here's the deal. Angle-angle already works. So any one of these with 2 A's in it is going to be a valid triangle similarity condition. I don't need to test it because it's already true because of angle, angle. So all of those are just redundancies that I'm just going to get out of there. I don't want to worry about those just because it's more information than I need. So I'm really just left with 2 that I need to investigate. All right, so here we are. We are going to test side, side, side similarity. I'm going to go ahead and link the sides here, and then I'm just going to monitor what happens as I move the edges around. Now I'm going to keep a close eye on these ratios here on the left. I want to make sure that they stay the same. So I'm going to be monitoring those ratios as I move these vertices around. Now, the other thing I need to know, it looks like the ratios are staying the same, but I need to check in on these angle measures. So as I look at this, it appears as if I have 3 pairs of congruent angles here. It looks like I have a 30-degree pair, a 104-degree pair that's off the screen, and then the other option would be 46 degrees. So again, as I check these and as I put these angle measures in here, you will see that these angle measures are the same. So not only do I have 3 sides that have a ratio of 2, I have 3 pairs of angles that all have the same measure. Well, that meets my criteria for similar figures in which the sides are all proportional and the angles all have the same measure. So side, side, side similarity works. Now let's talk side, side angle. First, I want to help you see the difference between side, side angle and side angle side that we've already discussed. Side angle side is when the angle is between the 2 sides that we know. In side, side angle, the angle is not between the 2 sides. It is next to one of the sides. It is not in the middle. Side angle side, the angle is in the middle. We already know that this works. We need to test to see if side, side angle works. So again, let's look at our animation using our E tool. So again, I'm going to go ahead and link 2 sides. This time, I'm going to link one pair of sides, the other pair of sides, and now I'm going to link this 50-degree angle. I'm going to check my ratios here again as I move this around to make sure that they stay the same. It looks like this time the ratio is 1. My angles are all staying the same, and it looks like those still line up. So again, I'm just going to keep playing with this and see, is there any situation where they don't line up? And now as I look at this, I see that I have here one side that now has a different ratio. My angles are still 25. I still have a pair of sides that match up, another pair of sides, but I no longer have similar triangles because one pair of sides does not have the same ratio as the other. Let's see what else happens here. Yeah, as I line these up, I can see these triangles are not similar with each other. I'll go ahead and put them kind of directly on top of each other so you can see it a little bit easier. But I can see that I have 2 different triangles that have different angles. And because in this case it does not work, side, side angle is not a valid triangle congruence, or triangle similarity theorem, because sometimes I could have triangles that don't have equal ratios. Or I could see that this angle here is obtuse, and this is not obtuse up here. This I can see is less than 90. So these triangles are not similar. All right, so if you remember from a couple slides back, the only things we had to check were side, 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 and side, side angle similarity. Side, 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 of course, is a valid reason. So I'm going to add that to my list that I have from earlier in the week. This gives me 3 conditions that I will use as I make my flowcharts to justify why triangles are similar. My choices are angle, angle similarity, side, angle, side similarity, or side, side, side similarity.